Okay, guys, let's go over the review for scientific notation. These first two problems are written in scientific notation, and we are asked to write them in standard form. So 8.1 times 10 to the fourth is really 8.1 times 10 times 10 times 10 times 10, making this 8.1 a very large number. When your exponent is positive, as in example number 1, our number is going to be large. So we are going to move the decimal 4 places to the right. So we're going to move it 1, 2, 3, and 4. The decimal is at the very end. So 8.1 times 10 to the fourth is the same as 81,000. In our next example, we can see that our exponent is negative. This means our coefficient 2.73 is going to get smaller and smaller and smaller. So this time the decimal is going to be moving to the left instead of to the right. So we're going to move it 3 places to the left. So 1, 2, and 3. So again, when your exponent is positive, you're going to have a large number. And whenever your exponent is negative, you're going to have a very small number. Now here we have two numbers written in standard form, and we are asked to write in scientific. So remember, there are two parts to scientific notation. We have the coefficient, and then we have the power of 10. The coefficient, the decimal is always going to be where our coefficient is a number between 1 and 10 without 1 over 10. So you can see 8.1 is between 1 and 10. In this example, you can see the coefficient 2.73 is between 1 and 10 without 1 over 10. So that is the goal. So the decimal starts at the very end, is understood to be right here, and we need to move it until we have a number, a coefficient that is between 1 and 10. So we're going to have 7.51. 7.51 comes between 1 and 10 without 1 over 10. This digit needs to be a single digit when we are writing in scientific notation. Now it's going to be times 10, and we need to identify what the power is. So how many times did we move the decimal? 1, 2, 3, 4, 5, 6, 7. So it's raised to the power of positive 7. In number 4, we are going to have a negative exponent because we have a very small number, and we need to identify where the decimal is going to be when we write it in scientific notation. So we're going to move the decimal 1, 2, 3, 4, 5. So we have 1.03, that's the coefficient that is between 1 and 10 without going over 10. And then it's times 10 to the negative 5 because we had this very small number and we were moving the decimal to the right. Now let's practice operations with scientific notation. So in number 5, we have a scientific times a scientific. We are going to bring in our power rules where when you are multiplying powers with the same base, you add the exponents. So the first thing we need to do is multiply the coefficient. So we have 5.7 times 3. 3 times 7 is 21. Write your 1, carry your 2. 3 times 5 is 15, plus 2 is 17. We have one digit that we're going to move over. So we have 17.1 times 10, and we are going to add exponents because that's what the product rule says. So it's 10 to the 8th. Now, before we move on, we need to ask, is this coefficient between 1 and 10 without 1 over 10? And it is not, it is 17. So we need to modify. So we need to go down and make it 1.71. And since we went down on the left side of our scientific notation, we need to increase the power on the 10 here. So it's going to be times 10 to the 9th. So that just keeps it balanced. Number 6, we are dividing, and we're going to bring in that quotient rule where when you're dividing like powers, you subtract your exponents. But first we have 3.2 divided by 8. So the top goes in the box when you're dividing longhand. 8 goes into 3 0 times. 8 goes into 32 4 times. And so we get 0.4 times 10. And we're going to subtract 5 minus 3 gives us a power of 2. Then you need to ask, is the coefficient between 1 and 10? And it is not. So we need to increase the coefficient. So I'm going to go up on the left side to make it 4 because 4 is between 1 and 10. And we need to go down on the right side, so 10 to the first or just 10. On number 7, we're adding. And we are going to write each of these out in standard form and then line up decimals. And that is going to be the process. So we have 9 times 10 to the 5th. So the decimal is here. So we're going to move it 1, 2, 3, 4, 5. Plus, here we have 6.2. And we are going to move the decimal 3 places. So that's 1, 2, 3. Now remember, when you're adding and subtracting decimals, you line up decimals. And our decimals are at the end. So I'm just going to line up 6,200 underneath this 900,000. So I have a 0, a 0, a 2, and a 6. So the decimals are at the end. We line them up. 0 plus 0, 0 plus 0, 0 plus 2, 0 plus 6, 0, and 9. Now this is standard form, and we are asked to write it in scientific. So we're going to have 9.062 times 10, and we move the decimal 1, 2, 3, 4, 5 times. Number 8, we're going to use the same process as number 7, but we're going to subtract. So we have 2.8 times 10 to the negative 3. We're going to move the decimal 3 places to the left. 1, 2, 3. Minus, and we're going to move our decimal 4 places to the left. So the decimal is here behind the 6. So 1, 2, 3, 4. And we're going to line up decimals and subtract. So I have 0 point, and then we have 0, 0, 0, 6. And we are going to subtract. 6 minus 8 is 2. 0 minus 2 is 2. 0, 0 in our decimal. Now we need to convert this to scientific. So we're going to have 2.2 times 10 to the negative, and we move the decimal 1, 2, 3 places. So I hope this helps.